He knows the formal definition of a derivative. He knows how to find f prime from the graph of f. He is an expert at tangent and secant lines. He can even divide by 0. He is the most interesting man in the world.
Don't drink and giraffe. Stay thirsty, my friends.
Will you marry me?
Oh my gosh, it's beautiful, yes!
Oh my god, I'm so excited. We're both engaged.
Oh my gosh, Ansley, your ring is beautiful. I love how it shows the slope of the tangent line of y equals x cubed at x equals 2.
Oh, Lauren, I love how your ring shows the graph of the tangent line at point A.
Tangent Jewelry. Open Monday through Friday till 8, Saturday and Sunday till 5. Online at tangentjewelry.com. Hello, ladies. Look at your graph. Now back at mine. Now back at your graph. Now back at mine. Sadly, they're not the same. But if you take the first derivative of your graph, put it next to mine, they'll start to look the same. X's and mins on your graph, or zeros on mine. Look at your graph. Now back at mine. Where your graph has a positive slope, mine's above the x-axis. Look down. Back up at me. Where your graph has a negative slope, mine is below the x-axis. Anything is possible when you know how to graph derivatives. I'm on a horse.
Ordinary cars have to follow the curve of the graph to get from point A to point B. But the 2004 all-terrain secant vehicle can travel in a direct path along the secant line from point A to point B.
Shoulder sideways, smack it in the air.
And now, back to the show.
Okay, so the first problem is using the formal definition of a derivative to find the derivative of f of x equals x squared. Okay, so the first step is to plug in to the formal definition. So you have the limit as h approaches 0 of x plus h squared minus x squared all over h. So then you want to just distribute this out and FOIL it out. So then you have the limit as h approaches 0 of x squared plus 2hx plus h squared minus x squared on the top over h. And then the next step is just to simplify. So you have x squared here and minus x squared there, so those cancel out. And then for the h's, since those are both divisible by h, you can cancel this out. So this becomes 2x, and this just becomes h. And then you take the limit. So you plug in 0 wherever you have an h. So then that gives you 2x plus 0, which is just 2x. So the derivative of x squared is 2x.
In order to find the slope of the tangent line, you're going to find the slope of a curve y equals f of x at point P. So the question asks, find the slope of the tangent line using the graph f of x equals x squared minus 2 at point 3, 1. So using the formal definition of a derivative, you're going to use f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Then plugging in the function, it'll be the limit as x approaches 0 of x plus h squared minus 2 minus x squared minus 2. So go ahead and multiply out the x plus h squared, and you'll get the limit as x approaches 0 of x squared plus 2xh plus h squared minus 2 minus x squared plus 2 all over h. And you'll find that a lot of the terms can simplify and cancel out. So the x squared and then my negative x squared cancel out. The negative 2 and the positive 2 cancel out. And then the h on the bottom and the h on the and one of the h's on the top can cancel out, leaving you with 2x plus h squared. So go ahead and evaluate the limit. So plug in 0 for h, and you end up getting 2x as your function. So the derivative equals 2x, and then it says find it at 0.31. So you're going to plug in 3 for x. So f of 3 equals 2 times 3, which is 6. And so the slope of the tangent line of the curve x squared minus 2 at 0.31 is going to be 6.
Okay, to find the derivative, or the graph of the derivative, you have to first find the derivative of the equation, which is 2x. And then you find the min of this graph, which is at 0. And because it's a min, it's going to be a 0 on your derivative graph. And then you're going to, because this is a negative slope from negative infinity to 0, it's going to be below the x-axis. And because it's a positive from 0 to positive infinity, it's going to be above the x-axis.